Welcome back to this course, Introduction to Blockchain Cybersecurity, a presentation of coding boot camps. This is lesson 4. This is a review of some basic blockchain security concepts. So let's take a look at the foundation of blockchain security. Well, a big part of blockchain security is the hashing function. And you may think of the hashing function as converting text into some unreadable string, and that's almost like encryption. And that's not really what hashes are used for on the blockchain. So hashes are digests of data. So any data value can be stored in a fixed alphanumeric string. And there are several, many, perhaps dozens of hashing algorithms. MD5 is popular, SHA-1, SHA-256. So we're taking a look at an example here of MD5, which hashes data into a 32 character string. So if we look here, the string here, what is blockchain, is hashed into this 32 character string. And if we look here, this 1 million with the commas is hashed into this 32 character string. And 0 is hashed into this 32 character string. What hashes are used for is not to hide the message here. It is to validate that the message has not changed. Hashes are very sensitive to any kind of change. If we would remove the commas here, we wouldn't necessarily change the numeric value. However, the hash would change. If we would say 0.0, we haven't changed the numeric value. However, the hash would change. So we would see any kind of change. And that really is the basis of why blockchain is immutable. All blockchain data is hashed, and that hash is reused in the next block and the block after that, in almost like a tree or a chain type of structure. There, if any previous block changes, that'll change the hash, and we'll know. And since the blockchain is distributed on many nodes, the blockchain or the blocks that have been tampered with can be dropped, and then it can be essentially rebuilt from a different node or restored from a different node. So hashing is meant to detect any kind of change in previous data or any kind of tampering with data. And then there is the cryptographic keys. So here we can see that it is we use a double key encryption for any kind of data. And this is where the data is actually encrypted. So we can see here that every user on the blockchain has two keys, a private key and a public key. So Tom wants to send a message to Kelly, and he will use Kelly's public key. That's almost like an address that everybody's aware of. So everybody knows Kelly's public key. So he uses Kelly's public key to encrypt the message. It says, "Hi, Kelly," becomes encrypted by her public key. We get this that no one else can read, and the message is received by Kelly, and Kelly uses her private key to decrypt the message. So only Kelly can decrypt this message. So we use double key encryption every day. If you ever see the site or the web address HTTPS when we go on e-commerce, or if we're looking to update any sensitive data, HTTPS uses the same thing. It does a quick update or exchange of keys, so the application, the web application, can validate that the requester, which is the user, is who he or she says they are. Now, what can happen with blockchain is the loss or the hacking or the insecurity of the private key, because control of the private key is critical in working on a blockchain. If a user's private key would become compromised or they would lose control of it and somebody else had it, then another user, a bad actor, could take control of his or her data on the blockchain. So it's very important to secure your private key. So in summary, we discussed hashing and how hashing is not a way of encrypting data, it's really a way of detecting any kind of changes in data. And we did talk about double key encryption. So our next session is going to be advanced blockchain security. And also, please, we've talked about this, but please do consult your learning materials. And if you're interested in any kind of private sessions, private learning for blockchain. And thank you again for watching this session. We'll see you in the next session.